In this video, we're looking at a circuit that's going to require Kirchoff's laws for the solution. And we're doing this in the introductory physics style, which is a little different from what you'll see in electrical engineering. And we're given a little bit of guidance this time. We're asked to set up two equations using the Kirchoff current law. So that's the idea that all the current entering a node will be equal to all the current exiting that node. And we're asked to set up three equations using the Kirchoff voltage law. And that's the idea that the sum of the voltage changes around any closed loop must vanish. Finally, we're asked to use a computer algebra system to solve the system of equations that we generated in part A and B. We have 5 unknown branch currents in this circuit. We have 5 equations now, and then we can plug into a computer algebra system and get decimal approximations for all these currents. So I'll go ahead and pick this node to begin with. And I see a current of I1 flowing into that, and the current I3 is also flowing into that, and then I2 is flowing out of that. So we say I1 plus I3 is equal to I2. I'll go ahead and pick the node that's in the middle for my second one. And I2 is flowing into that. And then what's flowing out of that? There's 3 currents flowing out of it. I3 is going upward, I4 to the right, and I5 downward. So there's our 2 Kirchoff current law equations. In part B, we're asked to set up our 3 equations with the Kirchoff voltage law. And any closed loop will do. I'm going to go ahead and take this as closed loop number 1. Then below that, closed loop number 2. And to the right of that, closed loop number 3. And we'll get 3 equations out of this. Now recall that if we cross over a resistor as we're traversing one of these loops in the opposite direction of the current, that's a voltage increase given by Ohm's law, V equals IR. If we cross over a resistor in the same direction as the current, that's a voltage decrease given by Ohm's law. And then when we cross over a power source, if I go from the positive to negative terminal, that would be a drop in voltage. If I go from the negative to positive terminal, that's an increase in voltage. So I'm going to go ahead and start at the lower left corner of this first loop and traverse it clockwise. And the first thing I do is cross the 1.8 ohm resistor opposite the direction of I3. That's a voltage increase given by 1.8 I3. Then I cross over the power source from the positive to negative terminal, so I get minus 4.5. Then I cross over the 12 ohm resistor opposite the direction of I3. That's a voltage increase of 12 I3. And finally, I cross over the 20 ohm resistor opposite the direction of I2, and I get a plus 20 I2. That's the sum of all the voltage changes on that closed loop, so that must be equal to 0. Then we move on to loop number 2, and I'm going to start this one at the lower left corner as well. And the first thing I cross over is the 9 volt power source from the negative to positive terminal, so I get 9 positive. Then I cross over a 1.5 ohm resistor in the same direction as I1, so that's a voltage drop. I get minus 1.5 I1. Then over the 20 ohm resistor in the same direction as I2, so that's a minus 20 I2. And finally over the 12 ohm resistor in the same direction as I5, so I get a minus 12 I5, and that's equal to 0. Finally, we traverse loop 3 clockwise, starting from its lower left corner. The first thing I cross is the 12 ohm resistor opposite the direction of I5, so I have a plus 12 I5. The next thing I hit is crossing over the 3 volt power source from the negative to positive terminal, so I have plus 3. And finally, we have a voltage drop over the 1.2 ohm resistor. I have minus 1.2. The current there was I4. And that's equal to 0. So again, we have 5 equations. We have 5 unknowns. Those are the 5 branch currents. And we go to our computer algebra system to solve the system. So I've already got the equations put into the system. Hopefully this makes sense. I named my variables with underscores to identify them as I1 through I5. And the name for our first equation is just EQN1 or equation 1, equation 2, and so on. Once we put all those equations into Maxima, I hit Shift Enter. And in the next step, this is how you solve a system of equations in Maxima. I use the solve command. And the first thing I do is put in my list of equations. And the next thing I do is put in my list of variables that I want to solve for. So those are all the i's. Now I put the word float out in front, which gives me a decimal output instead of fractions for my output. And I hit Shift Enter on this, and there's my list of branch currents. I'm going to go ahead and keep all of these to the thousandths place, and we'll have our final answer. So that's our final answer, but I do want to point out that 2 of these currents came out negative, and that's not a problem. It just means the direction we drew in the original circuit was the wrong direction for these currents. So in fact, I3 is going this way, through that top branch, and I5 is going upward through that middle branch. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.